Okay, in the last week's lecture, I explained the core concepts of this chapter 3, consumer behavior, right? So today, I'd like to explain in more detail the contents of chapter 3. So structure of chapter 3 is like this. Section 1, consumer preferences. So now everybody know what's the meaning of consumer preference? Indifference curve, indifference map, or the shape of utility function, right? Section 2, budget constraint. Everybody know this. Section 3, consumer choice. Consumer choice is consumers choose consumption bundles of two goods that should be on the budget constraint and touching highest indifference curve. And we already know that the first order condition of choice, slope of budget constraint P1 over P2 is equal to slope of indifference curve, MRS. And section 4, revealed preference. Section 5, marginal utility and consumer choice. And section 3, cost of living indexes. Okay? Now we go section 1, consumer behavior. Theory of consumer behavior. Description of how consumers allocate incomes among different goods and services to maximize their well-being, their utility. Okay? So consumer behavior is best understood in 3 distinct steps. Number 1, consumer preferences, utility function, indifference map. Section 2, budget constraint. So consumer's choice of consumption bundle should be 1 point on this budget constraints. And section 3, step 3, consumer choice, optimal condition for utility maximization, subject to budget constraint. What do consumers do? Recent models of consumer behavior incorporate more realistic assumptions about rationalities and decision making. A basic tool of economics, our model makes simplifying assumptions to explain much of what we actually observe regarding consumer choices and the characteristics of consumer demand. Actually, in the last lecture, I explained the core concept of this consumer behavior, the simplistic version, two good case, and cardinal preferences. But I'll explain a little later. But anyway, that kind of explanation is very strict version, not so realistic in real world. But so recent models of consumer behavior incorporate more realistic assumptions. So not cardinal preferences, right? So I said utility level 100, utility level 200 like this. This kind of numerics is not matter to derive consumer preference or indifference curve, just ordering matter. In this sense, we said realistic assumption. Section 1, consumer preferences. So market baskets. Market basket is equal to consumption bundles of two goods. Consumption bundles of two goods in this simplistic model, right? So consumption of food or demand for food, consumption of clothing or demand for clothing. So alternative market baskets, alternative consumption bundles of two goods. At point A, 20 food, 30 clothing. At point B, 10 food and 50 clothing, like this, A, B, D, E, G, H. Lots of consumption basket. To explain the theory of consumer behavior, we'll ask whether consumers prefer one market basket to another. Whether consumers prefer one market basket to another. So this is a starting point of theory of consumer behavior. Some basic assumption about preferences. Number 1, completeness. So now think about at point A, B, C, D, E, F, there are lots of consumption bundles. So consumer prefer consumption bundle A to consumption bundle B. then we said A prefer to B. And what that kind of A prefer to B happen? That means utility from consumption of two goods at point A greater or prefers to consumption bundle at point B. Okay? That is the meaning of this. Or, so A prefer to B, or prefer B to A, or will be indifferent. There are three cases when there exist two consumption bundles. A prefers to B, B prefers to B, to A, or indifferent. There are three cases. That is, we said, completeness. By indifferent, we mean that a person will be equally satisfied with either basket. So utility level from consumption bundle of A equal to utility level from consumption bundle B. That is the meaning of indifferent. Note that this preference ignores costs, ignores spendings, right? Ignores spending. For example, A indifferent to B, utility level same, but at consumption bundle at A require you spending $20, and point B require to spend $30, right? So cost different. Anyway, it doesn't matter in utility function. We just focus on utility level, satisfaction level. That is explained here. Note that this preference ignores cost. A consumer might prefer steak to hamburger, but buy hamburger because it is cheaper. Second assumption about preference is transitivity. Preference is transitive. What's the meaning of transitivity? If a consumer prefer basket A, consumption bundle at point A to point B, and basket B prefer to basket C, then we know A prefer to C. Why? A prefer to B, B prefers to C. Thus, A prefer to C. That is transitivity. Transitivity is normally regarded as necessary for consumer consistency. Number 3, more is better than less. What's the meaning of this? Simply talking, think about our utility function. More consumption of two goods leading new, more utility. That is the meaning of this. Goods are soon to be desirable. For example, to be good. Consequently, consumers always prefer more of any good to less. In addition, consumers are never satisfied or satiated. More is always better. More consumption, higher utility. Even if just a little better. Okay, there is 3. Based on these 3 assumptions, we can derive indifference curve and indifference map and utility function simply. So first look at this indifference curve. We already studied indifference curve. Indifference curve representing all combinations of market baskets or consumption bundles of two goods that provide the consumer with the same level of utility, same level of satisfaction. Describing individual preferences. Because more of each good is preferred to less, we can compare market baskets or consumption bundles in the shaded area like this. So now you are A. Compare A to E. E, at point E, you can consume more food and more clothing compared to point A. So the more, the better, higher utility, right? So E prefer to A. Also compare A to G. G, at point G, consumption of food and clothing should be smaller than consumption of two goods at point A. So utility at point G should be lower than utility level at point A. So market basket A is closely preferred to basket G, while E is clearly preferred to A. However, A cannot be compared with B, D, H. We cannot compare this kind of thing using this simple rule. Why? Think about A and B. Consumption of food decrease, so your total utility should decline. But consumption of clothing increase. Because of this, your total utility can increase, right? So because of this, we cannot be compared. Point A and B. Now, next slide. Indifference curve. The indifference curve U1, that is U1, that passes through market basket A shows all baskets, all consumption bundles that provide the consumer the same level of satisfaction, the same level of utility, as does market basket A. This includes basket B and D. At point A, you consume 20 food and 30 clothing. At point B, 10 food and 50 clothing. So composition of market basket changes. But anyway, total utility from these two consumption bundles, same at point A and point B. That is meaning of indifference curve, right? So, or think about A and D. At point D, consumption of food increase from 20 to 40. Because of this, total change in total utility increase, or change in total utility increase, marginal utility positive. But consumption of clothing decrease from 30 units to 20 units. Because of this, total utility from consumption of clothing decrease. Change in total utility because of decrease in clothing consumption is negative, right? Marginal utility from clothing, negative. Marginal utility from food consumption, positive. So in sum, same. Total utility same. That is the meaning of indifference curve. Our consumer prefers basket E, which lies above U1, but prefers A to H or G, which lie below U1, right? From here, indifference curve crossing point E should be like this. Higher utility than earlier one, U1, okay? So you can graph indifference curve crossing point G. That should be like this. This one should be lower utility than U1. Indifference map. Indifference map graph containing a set of indifference curves showing the market baskets, consumption bundles of the good among which a consumer is indifferent, right? There are larger, we can draw infinite numbers of indifference curve. That is indifference map. And in the last lecture I said this indifference map is equivalent to utility function, U function of food and clothing consumption. Okay? An indifference map is a set of indifference curves that describes a person's preferences. Any market basket on indifference curve U3, such as basket A, is preferred to any basket on curve U2, which in turn is preferred to any basket on U1, such as point D. Right? So think about transitivity. B preferred to A preferred to B, so A preferred to D. Okay? Important point anyway, indifference map. Indifference map, I'd like to, indifference map is equivalent to utility function at clothing. Okay, mathematically, that one. That is indifference map. Okay, now think about some features of indifference curve. Number one is this. Indifference curves cannot intersect like this. right? That kind of thing is not possible, right? So anyway, you studied this in Menkes Introduction to Economics already, how to prove this kind of thing. So in here, A prefer to A and B are on the same indifference curve. That means utility level from A, food consumption at point A, clothing consumption at point A, to reading you some satisfaction level, right? This one is equal to utility level from consumption basket at point B, food consumption at point B, and clothing consumption at point B, A to B, isn't it? Right? Also, think about indifference curve in labeled U2. At U2, A prefer to A indifferent to D, providing the same utility function, right? Then what kind of thing happen? A prefer to B, A indifferent to B, A indifferent to D, right? So then, because of transitivity, our earlier assumption, A prefer to B prefer to D, right? In other words, utility level at point B, FB, CB is equal to utility level FD, CD, right? If indifference curve can cross with each other, then we can derive this kind of conclusion, right? But that is not the case. Violates our earlier assumption that I'm sorry, the more consumption leading to higher utility, right? Look at this graph again. Now compare point D and point B. At point B, consumption of food increase compared to consumption of food in point D, right? Also, consumption of clothing at point B increase greater than clothing consumption in point D. In other words, right? We know FB, I'm sorry, I'd like to use this one. FD high greater than FB, right? For example, 3 food and 12 consumption of food at point B. I'm sorry, the opposite, isn't it? Point B, like this. Also, clothing consumption, that kind of thing happen, right? At D, for example, 15 and 16, like this. From here, then, what happened? Utility from point B, right? For example, I'd like to use numeric numbers. For example, 12, 16 should be greater than utility from 10, 15, isn't it? Right? That is our basic assumption. The more consumption, more satisfaction, more utility, right? 12 greater than 10, 16 greater than 15, right? So this result, that means simply talking, B prefer to D, right? Graphically, from this graph, we confirm that B prefer to D. More consumption of two goods leading to higher utility. But if two curves cross, we can conclude that B indifferent to D. So quite different, isn't it? So then why this kind of inconsistency happen? Our earlier assumption that, earlier arguments that U1 and U2 can intersect, right? The argument that U1 and U2 can intersect is false, simply talking. False assumption leading to this inconsistency. Can you understand? That is a way how to prove how to prove indifference curve cannot intersect. Okay? Then you go next one. Consumer preferences. The shape of indifference curve. The marginal rate of substitution. We already studied that. What is the meaning of marginal rate of substitution? Right? In this figure, the magnitude of slope of indifference curve measures consumer's marginal rate of substitution between two goods. When we moving A to B, to get one additional food, you have to reduce consumption of clothing by 6 units, right? When you moving B to D, if you want to consume one more food, you have to reduce 4 clothing. When you're moving D to E, to get one more food, only 2 clothing sacrificed. Here, just 1 sacrificed. So, MRS decrease and decrease and decrease. So, graphically, so now think about indifference curve. One indifference curve is like this. Utility level is U0, for example, right? That is clothing consumption and food consumption, original function. Then, when you're moving here to here, we can construct this kind of triangle, this kind of triangle, this, and this. From here, we know, anyway, gradient of these triangles are changing rate, right? Changing rate. Changing rate is -6, -4, -2, -1, like this. So this can be represented like this. X variable same f. That is changing rate, change in state over change in changing rate, change in C over change in F. That in this situation, -6, right? -4, -2, -1, like this. So we can draw changing rate is like this, right? That is changing rate of this indifference curve, one indifference curve. And I explained that absolute numbers of this one is change in C over change in F, right? Absolute numbers of -6, 6, -4, 4, 2, -2, 2, -1, 1, like this. Then we can draw this kind of slope, right? That is changing rate, and this one is slope, change in C over change in F, okay? That is MRS. Okay, that is my definition. But our textbook do not use some clear distinction between changing rate and MRS, slope. Anyway, it doesn't matter, right? So that kind of thing happens. So the shape of indifference curve means is this one. Negative decreasing slope case. Negative increasing changing rate case. We already studied that at the first lecture. Changing rate function means negative increasing changing rate case. Changing rate case. Okay? Or we can say this one. What happened? Negative decreasing slope case. Right? The slope is MRS. Negative decreasing slope case. That is explained here. The marginal rate of substitution, maximum amount of good that the consumer is willing to give up in order to obtain one additional unit of another good. That is marginal rate of substitution. Okay? So convexity. Convexity. What's the meaning of convexity? Original function shapes convex. That is convexity, right? convexity of indifference curve can be illustrated by mathematical notation. What is that? Negative decreasing slope case. MRS decreasing and decreasing. Right? So convexity, convex shape of convexity of indifference curve is illustrated by decreasing slope. Okay? So convexity is explained based on this original function. Also, this convexity is mathematically explained using the slope or changing rate concept. Okay? Observe that the MRS falls as we move down the indifference curve. The declining in MRS reflects our false assumption regarding consumer preferences, a diminishing marginal rate of substitution. Diminishing marginal rate of substitution, decrease and decrease and decrease. MRS decrease and decrease and decrease as F increase, X variable increase. When the MRS diminishes along indifference curve, the curve is convex. That is fourth feature of consumer preference. Okay, now some application. So using the shape of indifference curve, we can define some abnormal case. So extreme cases, two extreme cases. Number one is perfect substitutes. Food consumption, X variable and Y variable is perfect substitutes. Right? And perfect complements. Perfect complements that X and Y have some features can be explained using the shape of MRS, for example, right? So perfect substitutes, two goods for which the marginal rate of substitution of one for the other is constant. For example, 1,000 note is equivalent to 10 100 coin, isn't it? Korean won coin, right? That is a perfect substitute case, really extreme case. In this case, this perfect substitute case like this. For example, X variable, Y variable. Then indifference curve is straight line. In other words, MRS is constant. Okay? That is perfect substitute case. The other extreme case is perfect complement. That is shaped like this. Right? Like this. Indifference curve shaped like this. Okay? So, for example, 1,000 note is equivalent to 10 100 coin. Right? So, like this. But usually, indifference curve shaped like this. MRS is decreased. But in this case, MRS is constant numbers. Some constant numbers, right? Constant numbers. And in this case, MRS is equal to 0 or infinite numbers. Okay? So, perfect complement, two goods for which the MRS is 0 or infinite. The indifference curves are shaped as right angles. Anyway, that is goose case. Goose case means more consumption of two goods leading to higher utility. This one same, right? Indifference curve shaped like this, right? The opposite concept of goods is bad. Bad. Good for which less is preferred to rather than more one, right? So this one preferred to U2, U3, U4 like this. That is goose case. But this one preferred to this, U3 preferred to U2, U2 preferred to U1. That means less consumption, your utility increase. That is a case of Bayes. Now, here, figure 3.6, perfect substitutes and perfect complements. In A, X variable is orange juice, Y variable is apple juice. Bob views orange juice and apple juice as perfect substitutes. He is always indifference between a glass of one and a glass of the other, one-to-one relations, right? In B, Jane views X variable is right shoes, Y variable is left shoes. Jane views left shoes and right shoes as perfect complements. In addition, left shoe gives her no extra satisfaction as she also obtains the matching right shoes. So now think about here. One right shoes, one left shoes. Your utility level is, for example, 100. Now, keeping left shoes 1, you increase right shoes 1 and 2, 1 and 2 and 3, 3 and 4. Then what happens? Your total utility same at this point. Utility level at this point is same to utility level at this point, and utility level at this point, and utility level at this point, isn't it? Why? Only right shoes increase without increasing left shoes. So doesn't increase your total utility. That is perfect complements case. So I'd like to go example. So example 3.1, designing new automobiles. Preferences for automobile attributes can be described by indifference curve. There are two important attributes of automobile when you purchasing. Number one, acceleration, right? So young guys prefer acceleration. But another important attribute of automobile is space. Space. So more space means more person can ride the same car, isn't it? So that is also another attribute. So each curve shows a combination of acceleration, x variable, and interior space in y variable that give the same satisfaction, like this. One guy's indifference curve is shaped like this, right? The other guy's indifference curve shaped like this. What's the meaning of this? Look at this. Owners of Ford Mustang sports car, right? Ford Mustang coupes, sports car, are willing to give up considerable interior space for additional acceleration. So now think about young guys prefer speed than space, simply talking. So to get additional speed, acceleration, young guys are willing to sacrifice lots of space. So MRS, simply talking, MRS of acceleration is very high, right? But think about the opposite case here. To get additional acceleration, they really wants to give up little space because, for example, household, right? Head of household prefer space to acceleration. Then indifference curve shaped like this, right? So two guys have different preferences when purchasing a car, simply talking like this, like this. So this different shape of indifference curve or indifference map, we can check the differences in preferences. Okay, utility and utility function. Utility, numerical score representing the satisfaction that the consumer gets from a given market basket, consumption bundles of two goods, in this case, food and clothing, right? Utility function. So utility level 25, 50, 100, like this. Utility function formula that assigns a level of utility to individual market baskets, right? That is utility function. As I said before, this utility function, right? Figure 3.8, utility function and indifference curve. A utility function can be represented by a set of indifference curve. In other words, indifference map. I already emphasized that utility function can be illustrated by indifference map, right? Each with a numerical indicator. This figure shows three indifference curves with utility level 25, 50, 100 respectively, associated with the utility function you skipped here, UFC, right? Ordinal versus cardinal utility. ordinal utility function that generates a ranking of market baskets in order to most to read prefer to. That is ordinal one, right? So, and cardinal utility function describing by how much one market basket is preferred to another, right? Cardinal utility function, utility level 100, 110, 120, that is cardinal utility function, right? But ordinal utility function means just order matter, right? Just order which one prefer to the other. But we don't know. We cannot transforming into numbers. That is ordinal utility function, right? More realistic utility function in real world. But cardinal one is very strict, strong version of utility function. How much one market basket is preferred to another, right? So in the last lecture, I summarized section 3 using this cardinal utility function. Example 3.2. Can money buy happiness? Income, so income and happiness. Here, X variable is per capita GDP relative to US, right? Lots of countries. Just household, individuals, countries, I think. And the Y variable is satisfaction with life. So that is indicator of utility of each country. So now think about this. I don't know which country is dotted like this. This country's happiness level, utility level is this one. But the per capita GDP is some 16,000. Now think about this country. Per capita GDP is almost 35,000. And happiness level is above 7. Right? Like this. So one dot means pair per capita GDP and utility of one country. So there are lots of countries, so lots of dots here. Right? A cross-country comparison shows that individuals living in a country with higher GDP per capita are on average happier than those living in countries with lower per capita GDP. High-income countries, right? The people's happiness in high-income countries tends to higher than happiness level in developing countries or LDCs, like this, LDCs, right? This is high-income countries, middle-income countries like that. But just tendency. For example, this country, I don't know. This country's satisfaction level, utility level is very high, but per capita GDP is not so high, isn't it? So lots of Earth. But we can imagine that linear relations with X variable and Y variable like this straight line, right? So positive relation. We can graph a fitted value, fitted straight line like this. What's the meaning of this? X increase, then Y increase. So positive relationship between per capita GDP and utility level. So lots of students already studied econometrics, right? Econometrics, this dotted data can be projected this straight line. That is econometrics technique, minimizing errors, right? From fitted value and actual value, minimizing the errors between two. Summation of minimize the errors, right? Then we can project just straight line like this, and we can find positive relation, isn't it? Right? Okay, next we go section 2, budget constraint. Budget constraint is this one. P1, PF, F plus PC, C is equal to your income I. We already studied that, right? So rewriting this, C is equal to I over PF minus PC over PF F. C is consumption of clothing. F is consumption of food or demand for food, right? We already studied this budget constraint. Market baskets and budget line. Budget line is like that point A, food 0, clothing 40, total spending $8, right? Total spending. That is spending on food, spending on clothing. Summation of two spending cannot exceed your total income. Same to your income, right? So that is $80. Using this your income or total spending, you can purchase lots of combinations of two goods. 0, 40, 20, 30, 40, 30, 20, 60, 10, or 80, 0. Okay? Anyway, you have an income. So your consumption choice should be 1 point on this budget line. Budget line, isn't it? Right? Market basket, consumption bundle of two goods associated with the budget line. So in this example, price of food is $1, price of clothing is $2, then F plus 2C is $80, right? Look at this. Budget constraint. Graphically, this budget constraint can be graphed like this. Food, clothing, right? Here, I is 80. Anyway, I'd like to use this notation. If your total income spent on food only, your total income spent on food only. So then no money left to purchase clothing, right? That is x-intercept, isn't it? This point. What is this point? At this point, consumption of clothing 0, right? Consumption of clothing C is equal to 0. This one disappeared. Then your total income spent on only food. Then how many food you can purchase with your whole income? I over PF. I over PF. Right? Similarly, now think about y-intercept. This means consumption of your total income spent on clothing only. Food consumption is equal to 0. Food consumption is equal to 0. You only purchase clothing. This one is equal to 0. Then maximum consumption of clothing is equal to I over P2, isn't it? Right? If we connect these 2 points, we can get this kind of budget constraint, this one. Right? This one is the same thing. C, y variable C is equal to y-intercept is I over PF. I'm sorry. P2 is PF. I'm sorry. What happened? Something wrong? Clothing. I over PC. What is wrong? I'm sorry. This one. Wrong explanation of this. This is PC. This is PC. This is PF. Right? So PF like this. And this one is PC. What I'm talking? PF, PC. Okay? So that is budget constraint, original function of a budget constraint. From here, we can calculate changing rate of budget constraint, right? Like this. Same F, 0, change in C over change in F of this budget constraint. Slope of this one, slope of this one, changing rate of this one is this one, isn't it? Right? So changing rate, that is negative constant changing rate case. Right? So like this, that is minus PF over PC. Changing rate is this one. Now think about this kind of function. Y equal A minus BX. Right? Then changing rate, first derivative of this function, more accurately dy over dx. dy over dx is equal to what happened? Limitation change in x approaching to 0, change in x, change in y. Instantaneous changing rate, right? This one is equal to minus p, isn't it? Right? So now look at this. So changing rate is minus pf over pc. That is changing rate. Right? The slope of this one. What is slope of this one? Slope is absolute numbers of changing rate. So changing rate is equal to changing rate is slope is equal to just P. I'm sorry, PF over PC. Right? PF over PC. Right? So we already started in the graph. Negative constant changing rate case. Negative, the slope changing rate is below 0. Negative constant changing rate case. This one is equivalent to negative constant slope case. Right? This. Can you understand? Right? So a budget line describes the combinations of goods that can be purchased given the consumer's income and the price of the goods. Line AG, which passes through point BDE, shows a budget associated with the income of $80 here. The price of goods, PF is $1, PC, clothing price is $2 per unit. The slope of budget line is, so our textbook don't distinguish changing rate and slope. They use slopes and changing rate are almost the same thing, right, in our textbook. So minus PF, PC is minus half. That is changing rate. Slope is half in my notation. Okay? So write this. That is changing rate. Budget constraint. Okay, next slide. The effects of change in income and price. So number one, effects of a change in income on the budget line. Number one, income changes. So your income changes. A change in income, then what happens? Your income increases. Your income is I, or $80. This one increased to $100, right? This one changed to $80 to $100, but PF, PC, no change, same. Then what happens? Budget constraint shaped like this because income, I increased $80 to $100, isn't it? But changing rate, same. After increasing income, your income. Okay? If your income level is $60 instead of $80, then what happens? I decrease, PC same, I increase, PF same. So moving like this. Okay? That is income effect of income changes. Income increase, then budget constraint shift upward. Holding changing rate or slope same to earlier one. Parallel with each other. That means changing rate same. Right? Just shift upward or shift downward. Income increase, income decrease. That is effects of income changes. Right? Now, next slide. Effects of change in price on the budget line. At this example, what happened? A change in the price of one good with income same, $80, caused the budget line to rotate about one intercept. When the price of food falls from originally this one, price of food is $1, price of clothing is $2. Now, so originally, now this one, PF over PC. PF over PC, originally price of food is $1. Price of clothing, PF, PC. At original point, price of food is $1. Price of clothing, $2. So this one, changing rate, slope is half, right? But now, price of clothing same. PF, PC at point 1, for example. Price of food decreased to $0.50. Price of clothing same. Then what happened? Slope is false, like this. Right? Then what happened in this budget constraint? Right? Because price of clothing doesn't change, y-intercept same. But this one changes because price of food decrease. Right? So shaped like this way. So when price of food decrease to $0.50, for example, from $1, then budget constraint rotate to the right like this, right? If price of food increase to $2, right? $2 now rise to $2, $1 to $2, then slope is now 1. What is the meaning of this? Right? Moving shift to the left. Rotate to the left like this. Right? So price changes, then budget constraint rotate to the right or to the left. Right? That is explained here. When the price of food falls from $1 to 50 cents, the budget line rotates outward from L1 to L2. However, when the price increases from $1 to $2, then the budget line rotates inward from L1 to L3. Right? So price changes, then budget constraint rotates. Income changes, then slope same, but moving outward, shift to the right or shift to the left, like this. Right? That is budget constraint. Now we go consumer choices. The maximizing market basket must satisfy two conditions. It must be located on the budget line. Your choice of consumption of two goods should be one point of this budget constraint. That is number one. It must be located on the budget line. That means with your income, your choice, consumption choice should satisfy budget constraint. Right? That is step one. Number two, it must give the consumer the most preferred combination of goods and services. Right? So your consumption choice at this graph should be 1 point on this budget constraint, and you want to touch highest indifference curve. That is the meaning of number two. It must give the consumer the most preferred combination of goods and services. Okay? So now think about utility function. Can be represented by indifference map, isn't it? Indifference map is shaped like this. We already studied that, right? For example, we can draw lots of indifference map, right? Like this. There are lots of indifference map. That is this one. You want to touch highest utility level. That is number two. It must give the consumer the most preferred combination of goods and services. That is consumer's choice, right? So step one, graphically, 1 point on this budget line. Step number two, you want to touch higher utility, higher indifference curve. That is number two here. We already studied this, right? So in earlier studies, I said that if you choose this consumption bundle, right? Anyway, your choice should be 1 point on this budget. So you choose this point, then you can draw indifference curve crossing that point. Utility level is, for example, $80, right? If you're moving this way, you choose this point instead of this, then you can draw indifference curve crossing that point. Like this, utility level is $90. Your utility increase, right? About this, your utility increase again. You're moving this way. Your utility, you can touch higher utility indifference curve, right? Simply, now we're starting from the other side. You choose this one, then your utility level is just 60. If you choose this point, your utility level 80. How about this point? You're moving this way, utility level 90. Right? So you're moving this way, your utility increase. And finally, you can find one point where your utility maximize. At the same time, your choice should be one point on the budget constraint. That is here, this point. I said like this. We say utility level is just U star, for example. Right? We know that this point. That is consumer choice. Optimal consumption bundles of two-go. Right? Then what happened? This point, at this point, two cup, budget constraint, tangent with highest indifference cup, utility cup. Tangent means, anyway, we know that at this point, so that is F star, that is C star. So that is F star, at this F star, right? Slope of budget constraint is PF over PC. PF over PC, isn't it? At here, PF PC every time. And we already know that MRS. MRS is like this. MRS, that is MRS, right? MRS. We already started in the last week's lecture, isn't it? For example, at this point, indifference curve. At this point, utility curve is like this, and you can draw a straight line at that indifference curve. Then you're making this kind of steep triangle. And calculate MRS. MRS is this one, right? How about this point? You draw. You can think about this kind of imaginary indifference curve. At this tangent point, you can draw this kind of straight line and make triangle flatter than before, like this. In other words, decrease. Right? In this way, we can draw MRS shaped like this. And we know at this optimal consumption point, F star, C star, budget constraint touches tangent with indifference curve. That means slope same. Slopes of both curves are same. Right? That is condition for optimal consumption bundle. Slope of MRS is equal to slope of budget constraint PF over PC. This one is equal to this one. That is optimal consumption point. Also the condition of utility maximization, choice. Can you understand? Right? That is explained here. Okay, figure 3.13. Maximizing consumer satisfaction. A consumer maximizes satisfaction by choosing market basket A at point A, optimal point anyway, right? At this point, the budget line and indifference curve at this graph U2 are tangent. Two original functions tangent with each other. Budget constraint tangent with indifference curve. This indifference curve. Okay? So if that I already explained, but more strictly illustrating, we use first order condition. Slope of tangency means slopes the same, right? Two curves, original function tangent with each other. That means two curves have same slope at point, optimal point A. Okay? So we know that. No higher level of satisfaction can be attracted. At point A, the point of maximization, the MRS between the two goods equals the price of ratio at point B. However, because the MRS is greater than the price of ratio, satisfaction is not maximized. At point B, what happened? Right? At point B, I already explained indifference curve and MRS at point B is for example, 3, right? But slope of budget constraint at point B is 2, right? 2, but MRS is 3. So point B is not optimal point. Okay, then I'd like to stop a little.